Good morning, everyone. Today we are going to make a quick revision for all the science syllabus for this term. So let's begin. Okay, let's start by lesson 1, matter and its characteristics of unit 1. You have to know that what's meant by matter. Matter is anything that has mass and volume. So if I ask you what's meant by mass, it is the amount of matter in an object. And what's meant by volume, it is the space occupied by an object. If I ask you what are the measuring unit of mass, so they will be the gram and kilogram, the measuring unit of volume, cubic centimeter and cubic meter. Okay, if I ask you, I need to differentiate between all the matter around us. So we have two quantities to compare between them. We will compare about the physical properties and chemical properties. If I ask you, how can you distinguish the matter about their physical properties? We have 7 physical properties. The first one, we can differentiate between color, taste, and smell. We can differentiate between density. We can differentiate between hardness, boiling point, melting point, electric conductivity, and thermal conductivity. Now let's talk about the first one, which is the color, taste, and smell. For example, we can differentiate between gold and silver by their color. We can differentiate between table salt and sugar by their taste. We can differentiate between vinegar and perfume by their smell. Okay, so let's jump to the second one, which is the density. What's meant by density? Density, it is the mass per unit volume or mass of unit volume. For example, if I ask you what is the measuring unit of the density, it will be gram per cubic centimeter. Gram per cubic centimeter. Okay, all of us know that we have materials that have high density, so they can sink in water like metallic coin and iron nail because they have density higher than the density of the water. And we have materials that have density lower than the density of water, so they can float over the water like ice, wood, and drop of oil. Well, let's jump to the third one, which is a melting point. You have to know that there is a difference between the definition of melting and definition of melting point. Let's talk first about the melting. What's meant by melting? It is the changing from solid state to liquid state by heating. And what about the melting point? It is the temperature. It is the temperature at which is a solid change to liquid. Okay? We have two substances that have high melting point and substances that have low melting point. The substances that have high melting point, like all the metals, like iron, copper, aluminium, gold and silver, and so on. And substances that have low melting point, like ice, wax, and butter. Okay? Let's jump to the fourth one, which is the boiling point. You have to know, again, that there is a difference between the definition of boiling and definition of boiling point. For example, what's meant by boiling? It is the changing from liquid state to gas state by heating. And what about the boiling point? It is the temperature at which the liquid changes to gas. For example, we can separate the components of petroleum oil due to difference between their boiling point, because there is a difference between the component of the petroleum oil and their boiling points. You have to know that we have something called alloys. We have two examples for alloys. The copper gold alloy, which is used in making jewels, and nickel chrome alloy, which is used in making heating coils. Okay. Now let's talk about the hardness. You have to know that we classify the materials around us according to their hardness. We have materials that are soft at room temperature, like the rubber. Rubber is the only material that appears soft at room temperature. We have metals that can be softened, but by heating, like all the metals, and we have something or materials that can't be softened by heating, like coal and sulfur. For example, if I ask you, give reason question, the building concrete roads are made of iron, not copper, because iron is harder than the copper. Well, now let's talk about the electric conductivity. You have to know that materials are classified according to electric conduction into two categories: the good conductor of electricity and bad conductor of electricity. What's meant by good conductor of electricity? They are materials that allow electricity to flow. And bad conductor of electricity, they are materials that don't allow electricity to flow. Now let's talk about the examples on good conductor of electricity. We have the old famous example for good conductor of electricity, like all metals, iron, copper, aluminium. And we have new examples, which are the solutions: the acidic solution, salty solution, alkaline solution. And what about the bad one? We have the old example for sure, like glass, wood, plastic, and the new one, which is solutions, sugary solution, and hydrogen chloride in benzene. Now let's talk about the chemical properties. You have to know that we classify the metals into three groups according to their chemical activity: very active metal, less active metal, and inactive metals. What's meant by very active metal? They are metals that react with oxygen very, very fast when they exposed to humid air, like sodium and potassium. For this reason, sodium and potassium are kept under the surface of kerosene to prevent their reaction with oxygen, because they are very active metals. Now let's talk about the less active metals. They are metals that react with oxygen too, but slowly, not fast like the very active metals, but they react slowly and forming rust, like iron, copper, aluminium. For that reason, we should protect the ironwares that made of iron by painting white to protect them from rust, because they react with oxygen after long time. Now let's talk about the inactive metals. They are metals that find a great difficulty to react with oxygen. So it's not easy for the inactive metal to react with oxygen like the inactive one and the very active one. No, they don't react with oxygen under the normal conditions, like silver, gold, platinum, chromium, nickel. For that reason, jewels, for example, are made of gold and silver, because they are inactive metals that don't rust and find great difficulty to react with oxygen. Now let's talk about lesson 2 of unit 1, matter and its construction. Like you know before, that all the living organisms consist of small building units, which are called the cells. Now, similarly, the matter around us, every matter consists of small building unit inside it, which is called molecule. And every molecule in any state, whatever, solid, liquid, gas, have some properties. What are these properties? All the molecules are in a state of continuous motion. All the molecules have space between them that's called intermolecular spaces. All the molecules have a force that binds them together, which is called intermolecular force. Okay, now let's talk about the first property of the molecule, which is the continuous motion. For example, if we open a bottle of perfume and spread it for a while, leave it for a while, what happens? You will smell the odor of perfume all over the room. Why? Because the molecules of the perfume are in a state of continuous motion with the air. Now another example, if we drop a drop of ink in a water, what happens? The ink will spread in the water. Why? Because the molecules of the ink are in a state of continuous motion with the water. Okay? Now we need to talk about the motion of the solid molecules, the motion of the liquid molecules, and the motion of the gas molecule. All of us know that the molecule of solid are narrow, they are closer to each other. So the motion of solid molecule is limited vibrational motion. And what about the liquid molecule? The molecule of liquid are apart from each other, so the motion of the liquid molecule are more free. But what about the gas molecules? The gas molecules are very apart from each other, so they are completely free. So if we compare between the motion of the solid molecule, liquid molecule, and gas molecule, we find that the solid, limited vibrational, liquid, more free, gas, completely free. Now let's talk about the intermolecular spaces. If we made an experiment, if we have a graduated cylinder contain 20 cubic centimeter of alcohol and another graduated cylinder contain 30 cubic centimeter of water, and we bring the two cylinders and empty them into a new one, what happened? We will find, or we will observe, that the volume of the mixture will be less than their sum, less than 50 cubic centimeter. Why? Because the molecules of the alcohol will occupy or enter between the intermolecular spaces of the water molecules. Okay? So if I ask you what's meant by the intermolecular spaces, they are spaces that found between molecules. Now let's talk about the intermolecular force. What happens if you try to break a piece of iron with your hand? It will not break. Why? Because there is intermolecular forces between the molecule of the iron piece. So I need to know what is the intermolecular force in the solid, intermolecular force in liquid, and intermolecular force in gas. The intermolecular force between the solid molecule is very strong force, but in liquid it's a little bit, it's medium or weak. But in gases molecule, they are very weak intermolecular force between the gases of the between the molecule of gases. And we don't set what about the intermolecular spaces in solid, liquid, gas? The intermolecular spaces between the solid molecule is narrow. There is very small spaces between the solid molecules and each other. And what about the liquid molecule? Their spaces. The liquid molecules, the space between them, it's medium or large. And in gas, the intermolecular spaces is very large. Well, now let's talk about the shape and volume. The shape and volume of solid, liquid, gas. All of you know that the solid has a definite shape and definite volume. Shape that doesn't change, volume that doesn't change. But in liquid, the liquid have indefinite shape but definite volume. All of you know that the liquid take the shape of container, so the shape of the liquid changes. For this reason, the liquid has indefinite shape and definite volume. And what about the gas? The gas has indefinite shape, indefinite volume, shape that changes, volume that changes too. So if I ask you, give reason question, for example, why solid has definite shape and definite volume? The answer will be about the intermolecular spaces and intermolecular forces. For example, if I ask you, give reason solid has definite shape and definite volume, you will say because the intermolecular spaces in solid is narrow, but the intermolecular forces in solid is strong, and so on for the liquid and gas questions. Now let's talk about what happens if we heat solid molecules. When we heat solid molecules, the molecules of solid will gain heat energy. The molecules of solid will gain heat energy. And next step, the speed of the molecule increase. The speed of the molecule increase. Then the intermolecular spaces between solid become large. It was narrow, but it will be large. And the intermolecular force will be weak. Before it was strong intermolecular force. But now the intermolecular forces become weak. So the solid changed to liquid by heating, and this process called melting. So if I ask you what's meant by melting, is it changing from solid state to liquid state by heating. Now let's talk about what happens if we heat liquid molecules. The same steps. The liquid molecules now will gain more heat energy or more thermal energy. Then the speed of molecule increase, so the intermolecular spaces become very large, and the intermolecular forces become very weak. So the liquid changes to gas by heating, and this process is called vaporization. So what's meant by vaporization? It is changing from liquid to gas by heating. You have to know that the melting process is opposite or adverse for the freezing process, and the vaporization is adverse or opposite to condensation process. And like we said before, the matter consists of small building unit which is called the molecule. You have to know now that the molecules itself consist of small building units or structural building unit fundamental inside it, which is called atom. Okay, we said that the molecule consists of atoms. So we can classify or we can differentiate between the molecules according to the atoms of it. So we have two groups here. Molecules that consist of similar atoms, atoms like each other's. And we have molecules that consist of different atoms, atoms not like each other's. So we have two types of molecules, element molecule and compound molecule. What's meant by element molecule? It is the molecule that consists of similar atoms. And what about the compound molecule? It is a molecule that consists of different atoms. For example, for the element molecule, we have molecules that consist of one atom only and molecules that consist of two atoms. The molecule that consists of one atom only is called monoatomic molecule. Monoatomic molecule. We have example for the monoatomic molecule in the liquid state and gas state. The only liquid monoatomic molecule is mercury. Mercury is the only liquid monoatomic molecule. And what about the monoatomic gases? They are called the inert gases or noble gases, like helium, argon, neon, krypton, xenon, radon. So, if I ask you, give me example for monoatomic gas, it will be helium, argon, xenon, krypton. It's up for you. But if I ask you scientific term, they are the monoatomic gases. So don't write helium, don't write argon, no, I don't need example. I need the category itself. So you will write the noble gases or inert gases. Now let's talk about the diatomic molecule. What's meant by diatomic molecule? It's a molecule that consists of two atoms. And we have two examples for the diatomic molecule in the liquid state and in the gas state. The only diatomic liquid molecule is the bromine. And what about the gases? What about the diatomic gases? They are called the active gases, the famous gases in our atmosphere, like oxygen, nitrogen, hydrogen, chlorine, fluorine. Okay, now let's talk about the compound molecules. What's meant by compound molecules? They are molecules that consist of different atoms. We have some examples on a compound molecule like water molecule, ammonia molecule, hydrogen chloride, and sodium chloride. Let's talk about the first one, the water molecule. The water molecule, H2O, it is a molecule that consists of 2 hydrogen atoms and 1 oxygen atom. Different. And now let's talk about the ammonia molecule, NH3. 3 hydrogen and 1 nitrogen. Different. Now let's talk about the sodium chloride, NaCl. 1 sodium and 1 chlorine. Different. So they are compound molecules. And now let's talk about the hydrogen chloride. It consists of 1 hydrogen and 1 chlorine. Different. So if I ask you, give reason. Oxygen molecule is the element. But for example, water is compound. Why? Because oxygen consists of similar atoms. O and O, similar. But water molecule, because it consists of different atoms, like 2 hydrogen and 1 oxygen. Okay. Now let's talk about lesson 3, the atomic structure. Take care about this part because let's talk about the symbol of the element. How is the symbol is written? Take care. If the symbol consists of 1 letter only, so this letter should be capitalized or written in capital form. But if the symbol it consists of 2 letters, so the first one should be capitalized and the second one should be written in small form. Okay, for the symbol you have to remember the symbols very well. The symbols that has a Latin name or derived from Latin name like sodium, natrium, and like potassium, calcium. Take care from these symbols. Now let's talk about the atom itself. Let's jump inside the atom. If I ask you what is the atom consists of, you have to know that the atom consists of a central core inside it, in its center, which is called nucleus, and around it we have negatively charged particles that rotate with very high speed around it, which is called electrons. So if I ask you, the atom consists of 2 main parts, which are nucleus and negative electrons. Now let's jump inside the central core, which is a nucleus. We'll find that we have positive charged particle, which is called protons. And we have inside it 2 neutral or uncharged particles that called neutrons. So if I ask you a complete question, the nucleus consists of dots and dots. The nucleus consists of positive protons and uncharged or neutral neutrons. So we need to think, what about the charge of the nucleus itself? The nucleus consists of positive proton and uncharged neutron. So the positive will beat the uncharged. So the nucleus itself will be positive. Why? Because it contains positive protons and neutral neutrons. Okay, now let's look outside the nucleus. We have negatively charged particles that called electrons. Now we need to know more about the masses of the component of the atom, the mass of the proton, mass of the neutron, mass of electron. We found that the mass of the proton, it is the largest one, but the mass of electron is the smallest one. For that reason, the mass of the whole atom is concentrated inside the nucleus. Why? Because the mass of electrons around the nucleus are very small to the mass of the proton inside the nucleus. You have to know that the number of protons inside the nucleus equal to the number of negative electrons around the nucleus. For this reason, the atom is neutral, or the atom is neutral because the number of positive protons inside the nucleus equal to the number of negative electrons around the nucleus. The positive equal to negative. So the whole atom is neutral. Now let's talk about something it's very important, the atomic number and mass number. Each element has two numbers. Number is written at top left of it and number is written at bottom left. The number which is written at the bottom left is called atomic number, and number which is written at top left it's called mass number. What's mean by atomic number and mass number? The atomic number, it is the number of positive protons or negative electrons inside the element itself. For example, if we said that sodium has 11 protons, so the number of electrons will be 11 because proton equal to electron, and the atomic number will be 11 because the atomic number, it is the number of protons or electrons. And what's meant by mass number? Mass number, it is the sum of positive proton and neutral neutron. For example, if we said that magnesium, for example, has 12 protons and 12 neutrons. So the mass number is the sum of positive proton and neutral neutron. So the mass number will be 24. But if we need to calculate the number of neutrons only, the mass number is the sum of positive proton and the neutral neutron. But the atomic number, it is the number of proton only. So if you need to calculate the number of neutrons, you will subtract the mass number from atomic number. You will subtract mass number minus atomic number to find number of neutrons. For that reason, the mass number is always bigger than the atomic number. Why? Because the mass number, it is the sum of positive protons and neutral neutrons, but atomic number is number of protons only. Now you have to know that electrons move around the nucleus in places, but they are imaginary places. They are called energy levels. What's mean by energy levels? They are imaginary places that found around the nucleus, in which electrons move inside them according to their energy. So electron move inside the energy level according to its energy. And you have to know that we have 7 energy levels around the nucleus, which are arranged alphabetically in English letters: K, L, M, N, O, P, Q, 7 energy levels. The least energy level is K and the highest energy level is Q. And as the distance between the energy level and the nucleus increase, the energy will increase. Okay, now I need to ask you a question. If we have 7 energy level and we have electron in K, and this electron want to jump into L level, want to jump from here to here, can the electron move from this level to this level? Yes, but under certain condition. The energy of the electron must be equal to this energy of this level to move to this level. So the electron can't move to a higher level unless it gain energy. And this energy is called quantum. So what's meant by quantum? It is the amount of energy gained or lost by electron. And when the electron gain quantum, it will move to a higher level and it will called excited electron. But what happens if the excited electron lose its quantum? It will return back to its original level. So what's mean by excited electron? It is the electron that gained the quantum. Now we need to know the number of electrons that saturate each energy level. Okay, well, we have a rule. We have a rule to calculate the number of electrons in the energy levels. But take care, this rule is applied only for the first 4 energy levels only. Why? Because the atom after the first 4 energy level become unstable. For that reason, this rule is applied only for the first 4 energy level. And what is this rule? It is 2n power 2. 2n power 2. This rule helped me to know the number of electrons that saturate each level from K, L, M, N. We have to know that the K energy level is saturated by 2 electrons because 2 times 1 power 2 equal 2. The L energy level is saturated by 8 electrons. Why? Because 2 times 2 power 2 equal 8. The M energy level is saturated by 18 electrons. Why? Because 2 times 3 power 2 equal 18. The N energy level is saturated by 32 electrons because 2 times 4 power 2 equal 32. And we can't calculate the number of electrons in OPQ because we said that the atom after the first 4 energy level become unstable. Now let's talk about the electronic configuration, the drawing of electrons in their levels. You have to know that we have a rule to draw the energy level and their electrons. For example, the first energy level, K, it's only saturated with 2 electrons, and any level after K is saturated only by 8 electrons. If you have more electrons left, so okay, open a new level and draw these electrons. For example, if we have sodium, Na11, so it will be K2, L8, M1. Look above the outermost energy level, the last one, it has only 1 electron, or it's less than 8. So, if the outermost energy level of any element is less than 8, so this element is active and unstable. Active and unstable. So it can react with another element. Why? To be stable. Because it's not completely filled with electron. It's not completed by 8. So it can react with another element. Okay, another example. Argon 18, Ar18. It will be K2, L8, M8, 18. Look about the outermost energy level, 8. It's completely filled. So this element is inactive and stable. So it can't react with another element because it's already completely filled with electron and already stable. Take care, all the inert gases, all noble gases have 8 electrons in the outermost energy level, except helium, because helium, He2. The helium is the only inert gas that consists of 2 electrons in the outermost energy level. And all the inert gases are inactive and stable. Now let's talk about unit 2, which is energy. We have to know what's meant by energy. Energy, it is the ability to do work or to make any change. Okay, we have to know too that the measuring unit of energy is joule. So the measuring unit of energy is joule. And now I will tell you an example and take care about it. Attention. If we have an object in front of us and we give a force on this body, we push this body in this direction, and this body move in the same direction of the force. I push the body in this direction and the body move in this direction. So I made a work. So if we act on a body by a force and this body move a distance or displacement So it said that work is done. And we can calculate the work from a relation. We have a magic triangle, WFG, WFG. We calculate the work, force, and displacement. The measuring unit of work is like the energy, joule. The measuring unit of force is Newton. The measuring unit of displacement is a meter. If I ask you, give reason question, when we push a wall, we didn't do work. Why? Because the displacement is zero. The wall doesn't move, so we didn't do work. Now let's talk about the resources of energy. From where can I get energy? We have some resources of energy. The first one, the biggest resource of energy on the earth, which is the sun. The sun is the permanent resource and the biggest source of energy on the earth. We have also the wind energy, waterfall, food, fuel, and nuclear energy. All these categories, all these parts are resources of energy. Now let's talk about the forms of energy. What are the types of energy? We have many forms of energy like light energy, sound energy, heat energy, electric energy, potential, kinetic, chemical, nuclear. So let's begin by light energy. We can get light energy from sun, from electric lamp, from oil lamp. We can get heat energy from sun, from heater, from oven, from burning anything. We can get sound energy from any musical instrument, from any speaker. We can get electric energy. Take care. Electric energy is produced from solar cell. Solar cell, it's something like solar panels which are fixed on the top roof building. They convert or change the solar energy into electric energy. So we get electric energy from solar cell, and we can get electric energy too from a battery or dry cell. And now let's talk about the chemical energy. The chemical energy, it's not get, it's stored. It's stored. The chemical energy, it's stored in food, stored in fuel, stored in battery. Take care, don't conflict between there is energy stored in battery and the energy produced from battery. The energy stored in battery is chemical, but the energy produced from battery is electric. In the previous year, we talked something called potential energy and kinetic energy, but now in this year, we collect the potential energy and kinetic energy in one form, which is called mechanical energy. The mechanical energy is stored, not got, stored in the string of strings in the guitar, and also stored in waterfalls. Now, let's talk about the nuclear energy. Nuclear energy, from its name, it is the energy produced from nucleus. To ask you a give reason question, give reason. The developed countries aim to use the solar energy, wind energy, waterfall more than before. Why? Because, for example, the solar energy, it's cheap, clean, permanent, doesn't pollute the environment. And for wind energy and waterfall, they are renewable forms of energy, and clean, cheap, and doesn't pollute the environment too. Now let's talk about the potential energy. What's mean by potential energy? Potential energy, it is the energy stored in body due to work done. We have a body that's walk, it's make a work, then it's sit. So the energy is stored due to work done. So now we need to know what are the factors affecting the potential energy. We have two factors that affect potential energy, which is weight and height. Weight and height. For example, when the weight increases, the potential energy increase. Why? Because there is a direct relation between them. When something increases, another something increases, so there is a direct relation between them. And what about the height? When the height increases too, the potential energy will increase because there is a direct relation between them. So the potential energy is directly proportional to weight of the body and height from the ground. Okay? We can calculate the potential energy from rule in magic triangle. PE is potential energy, weight, and height. Potential energy is measured in joule because it's energy. Weight is measured in Newton. Height is measured in meter. But take care, in the problem, I give you only mass, not weight. So how can you get the weight? You will take the mass and multiply it by 10. It will give you the weight. It's easy. Then complete weight times height, and it will give you the potential energy. That's. Now, let's talk about the kinetic energy. What's meant by kinetic energy? The kinetic energy, it is the work done during motion. It is the work done during motion. Motion, it's kinetic energy. So, you need to know too that there are factors affecting the kinetic energy. What are these factors? Mass and speed. Again, when mass increases, the kinetic energy increases too because there is a direct relation between them. When the speed increases, kinetic energy increases because there is a direct relation between them. So, take care, when the mass is doubled, so kinetic energy is doubled. But when the speed is doubled, the kinetic energy increases 4 times. Why? Because in the rule of the kinetic energy, Ke, kinetic energy, equal half times m times v power 2. V power 2. So, for example, if the speed increase 2 times, so 2 power 2 equal 4. So when the speed increase 2 times, kinetic energy increase 4 times. Take care from this part. By the way, you can say speed or velocity, it's up for you. Speed like velocity. And we can calculate the kinetic energy from rule Ke equal half m v bar 2. And by the way, it's a direct question. The mass will be given, the velocity or speed will be given. All for you. You will write the rule and calculate. It's very, very easy. The measuring unit of kinetic energy, it's energy, so it is a joule. The measuring unit of mass, kilogram. The measuring unit of velocity, you will know the velocity from its unit, meter per second. Now let's talk about the mechanical energy. What's meant by mechanical energy? Like we said from before, that the mechanical, it is the sum of potential energy and kinetic energy. It's very easy, and it's a definition. The kinetic energy plus potential energy will give you mechanical energy. And it's a problem, it's rule, ME, mechanical energy, equal PE, potential energy, plus KE, kinetic energy. You have to know something. If we have a ball, tennis ball, and we hold the ball from at a maximum height, I hold the ball like this. At this point, what is the potential energy and what is the kinetic energy? The ball in my hand, fix it. So the height is maximum, so the potential energy in this point is maximum. And what about the kinetic energy? It is 0 because there is no speed. But when I throw the ball and this ball fall on the ground, so in this point, there is no height. So the potential energy here is 0. But the kinetic energy here is maximum. When the ball touches the ground, at the moment that the ball touches the ground, the speed is maximum. So kinetic energy is maximum. So at a maximum height, potential energy is maximum and kinetic energy is zero. At the ground, potential energy is zero, but the kinetic energy is maximum. Now let's talk about lesson 2 of unit 2, the energy transformation. If we have a pendulum string with a ball, this position is called original point. When the pendulum moves to right, it is a maximum point, maximum height. And which is moved from right one, it's a maximum height too. So I need to know the potential energy and kinetic in this point, and this point. At this point, the potential energy is maximum because height is maximum. And kinetic energy is zero because it's at rest, no velocity, no speed. At this point, the pendulum starts to move, so speed increase. So kinetic energy here is maximum and potential is zero because here there is no height. And when the pendulum moves at maximum height again, so in this point, like this point, here the potential energy is maximum, kinetic energy is zero. So I need to ask you a question. When the pendulum is left from maximum height, I leave the ball from here. I left the ball. So the potential energy is changed into kinetic energy. But when we push the pendulum, the kinetic energy changes into potential energy. Okay. Now you have to know that we have some energy transformation, something called simple electric cell. If we have a lemon and we dab two different metals in the lemon, and we connect these two metals with a wire to electric lamp, we'll find the lamp will light. Why? Because inside the lemon we have acidic solution which is good conductor of electricity. We made this model in large scale. We bring a glass container and fill the glass container with diluted acid called diluted sulfuric acid. Then we dab two different metals. One is copper and one is zinc. The copper is a positive plate and zinc is a negative plate. Then we connect the two metals with a wire to the lamp. The lamp will light too. Why? Because the acid inside the container, the diluted sulfuric acid, is a good conductor of electricity. You have to know that the electric current, the direction of the electric current move from positive plate to negative zinc plate, from positive copper to negative zinc, from positive copper to negative zinc. Okay, so I need to ask you, the simple electric cell changes dot energy into dot energy. Change the chemical energy into electric energy. The chemical energy in the diluted sulfuric acid into electric energy, which lights the lamp. Now another devices and its transformations. The electric lamp, for example, change electric energy into light energy. Washing machine from electric to kinetic. Sewing machine from electric to kinetic. Solar cell from solar to electric, battery from chemical to electric, cellular phones or mobile phone change electric into light and heat, TV from electric to light and heat, photosynthesis process from solar energy to chemical energy, a car dynamo or any dynamo from kinetic energy to electric energy. And you have a table in the sheet, revision sheet, for all the devices and their energy transformation. Now we have some negative effects of technology from devices or from application like car exhaust, military explosions, webs of cellular phone, chemical pesticides. For example, the car exhaust, it make a chemical pollution for air. Chemical pesticides, it make chemical pollution for air, water, soil, and led to food poisoning, for example, and led to cancer. Military explosions, it's called damage, death, and nuclear weapons, it make massive destruction. The webs of cellular phones make electromagnetic pollution. Now let's talk about lesson 3 of unit 3, the heat energy. We can get heat energy by many ways, like from sun or by friction. For the friction, we can change the kinetic energy into heat energy by friction. Like when you rub your hand together, you feel warm. Why? Because kinetic energy changes it into heat. Okay, I need to know what's meant by heat energy. It is a form of energy that's always transferred from higher temperature to lower temperature. Heat energy always move from hot to cold, not the opposite. Heat energy move from higher temperature to lower temperature. And what about temperature? What's meant by temperature? It is a heat condition. It is a condition that determines the direction of heat energy. It's helped me to know the direction of heat energy. So it's a condition to determine the direction of heat energy. You have to know that heat energy is transferred inside different material like solid, liquid, gas by 3 ways: conduction, convection, radiation. Heat is transferred by 3 methods or 3 ways: conduction, convection, radiation. Let's talk about the first one, conduction. Conduction, it is a method of heat transferring in solid only. So heat is transferred in solid by conduction from part of higher temperature to another part of lower temperature. So for example, when you put a metallic spoon in hot cup of tea, the metallic spoon will get hot. Why? Because heat energy is transferred in solid by conduction. And what about convection? Convection, it is a method of heat transfer in liquid and gas. In liquid and gas, where the hot molecules have lower density, so it moves up. But the cold molecules have high density, so it falls down, and so on. For this reason, we make ideas on this scientific base, like the air conditioner and heater, freezer. Let's talk about the heater. We put the heater at the lower part of the room. Why? Because when the air is heated, its density decreases, so it moves up. But the cold air have high density, so it will move down to be heated, and so on. And for the air conditioner, we put the air conditioner at the upper part of the room. Why? Because when the air is cooled, its density increases, so it will fall down. But the hot air has low density, so it moves up to be cooled, and so on. Like the freezer is put at the top of the fridge because the cold air has high density, so it moves down. But the hot air has low density, so it moves up again. Okay, so if I ask you a complete question, the heat of the heater reach us by dots, by convection. You only know convection till now, convection. And what about radiation? Radiation, it is a method of heat transfer in material media and non-material media. In radiation, you needn't to have a medium to transfer the heat, like from sun. The heat of the sun reach us by radiation. Why? Because there is a space between the sun and us. There is a space between sun and us. There is no air. So heat transferred from sun to us by radiation. What's meant by radiation? It is a method of heat transfer in material media or non-material media, or you can say in gas and space. So the heat of the heater, its heat reach us by convection, because convection move in gas, or by radiation, because radiation moving gas too. But the heat of the sun only reach us by radiation. So if I ask you, give reason. The heat of the the heat of the sun reach us by radiation only, not by conduction, not by convection, not by conduction because the air is bad conductor of heat, and not by convection because there is a space between sun and us, so it's only transferred by radiation.